Alternating current problem solving skills. Video 2. Problem. An alternating circuit diagram is given as shown on the right with an alternating power source of 100 sine of 120 pi t, and values of R sub 1, R sub 2, L sub 1, L sub 2, C sub 1, C sub 2, being shown on the circuit diagram. Find the voltage equation across the voltmeter V, vector U sub Mn, assuming that the resistance of the voltmeter is extremely high, and the current passing through it is zero. Solution. First thing first, resistances of the following electric devices should be calculated. 1 over C sub 1 ohmega equals 10 raised to the power of 6 over 265.2582 times 120 pi equals 10 ohms. 1 over C 2 omega equals 10 raised to the power of 6 over 106.1033 times 120 pi equals 25 ohms. L sub 1 omega equals 53.0516 times 10 raised to the power of negative 3 times 120 pi equals 20 ohms. L sub 2 omega equals 39.7887 times 10 raised to the power of negative 3 times 120 pi equals 15 ohms. R sub 1 equals 17.3205 ohms equals square root of 300, which is equivalent to R sub 1 squared equals 300. The magnitude of the current intensity vector I sub 1 is calculated as follows. I sub 1 magnitude equals U magnitude over square root of R sub 1 squared plus open bracket L sub 1 omega minus 1 over C sub 1 omega close bracket squared equals 100 over square root of 300 plus open bracket 20 minus 10 close bracket squared equals 5. The phase angle alpha that vector I sub 1 lags behind vector U is calculated as follows. Tangent of alpha equals L sub 1 omega minus 1 over C sub 1 omega over R sub 1 equals 20 minus 10 over 17.3205 equals 10 over 17.3205. So, alpha equals 30 degree. The equation of the current intensity, I sub 1, is as follows. I sub 1 equals I sub 1 magnitude times sine of 120 pi t minus 30 degree, or I sub 1 equals 5 sine of 120 pi t minus 30 degree. The vector diagram of vector I sub 1 with vector U being the reference vector is shown on the right. Because I sub 1 equals 5 sine of 120 pi t minus 30 degree flows through the inductor L sub 1, and because the voltage across an inductor leads the current in it by a phase angle of 90 degree, the voltage equation across the inductor L sub 1, U sub AM, is as follows. U sub AM equals L sub 1 omega times 5 sine of 120 pi t minus 30 degree plus 90 degree equals 20 times 5 sine of 120 pi t minus 30 degree plus 90 degree equals 100 sine of 120 pi t plus 60 degree. The vector diagram of both vector I sub 1 and vector U sub AM, with vector U being the reference vector, is shown on the right. Similarly, the magnitude of the current intensity vector I sub 2 is calculated as follows. I sub 2 magnitude equals U magnitude over square root of R sub 2 squared plus open bracket L sub 2 omega minus 1 over C sub 2 omega close bracket squared equals 100 over square root of 100 plus open bracket 15 minus 25 close bracket squared equals 10 over square root of 2. The phase angle alpha that vector I sub 2 lags behind vector U is calculated as follows. Tangent of alpha equals L sub 2 omega minus 1 over C sub 2 omega over R sub 2 equals 15 minus 25 over 10 equals negative 1. So, alpha equals negative 45 degree. The equation of the current intensity I sub 1 is as follows. I sub 2 equals I sub 2 magnitude times sine of 120 pi t plus 45 degree, or I sub 2 equals 10 over square root of 2 times sine of 120 pi t plus 45. The vector diagram with vector u, being the reference vector, is shown on the right. Now, take a look at the two components, C sub 2 and R sub 2, through which the current I sub 2 equals 10 over square root of 2 times sine of 120 pi t plus 45 degree flows. Resistance of these two electric components, R sub 2 and C sub 2, is as follows. R sub an equals square root of R sub 2 squared plus, open bracket, 1 over C sub 2 omega, close bracket, squared, equals square root of 100 plus 25 squared, equals 5 times square root of 29 ohms. Voltage vector U sub an lags behind the current vector I sub 2 by a phase angle alpha as follows. Tangent of alpha equals 1 over C sub 2 omega over R sub 2 equals 25 over 10 equals 2.5. So, alpha equals 68.1986 degree. The voltage equation of vector U sub an is as follows. U sub an equals R sub an times I sub 2 equals 5 times square root of 29 times 10 over square root of 2 times sine of 120 pi t plus 45 degree minus 68.1986 degree equals 25 times square root of 58 times sine of 120 pi t minus 23.1986. Both vector U sub am and vector U sub an are now presented on the vector diagram on the right. So, both voltage vector U sub am and vector U sub an have been determined. The voltage vector U sub mn is just the subtraction of one of these two vectors from the other. In this case, vector U sub mn equals vector U sub an minus vector U sub am. To calculate the magnitude of vector U sub mn, adopt the following formula to the triangle AMN. Mn squared equals am squared plus an squared minus 2 times am times an times cosine of the angle MAN. So, mn squared equals 100 squared plus, open bracket, 25 times square root of 58, close bracket, squared, minus 2 times 100 times 25 times square root of 58 times cosine of 60 degree plus 23.1986 degree, equals 10,000 plus 36,250 minus 5,000 times cosine of 83.1986 degree, equals 45,657.8588, or m north equals square root of 45,657.8588, equals 213.6780. To calculate the angle AMN, adopt another triangle formula. Mn over sine of the angle MAN equals an over sine of AMN, which is equivalent to sine of the angle AMN equals an over mn times sine of the angle MAN equals 25 times square root of 58 over 213.6780 times sine of 83.1986 degree equals 0.8848. So, the angle AMN equals 62.2224 degree. So, the angle ABM equals 180 degree minus the angle MAB minus the angle AMN equals 180 degree minus 60 degree minus 62.2224 degree equals 57.7776 degree. The answer to the problem is that vector U sub mn equals 213.6780 times sine of 120 pi t minus 57.7776 degree. This means that the voltage vector U sub mn lags behind the power source vector U by a phase angle of negative 57.7776 degree. If you are asked to find voltage equation of vector U sub nm instead of U sub mn, you subtract vector U sub an from vector U sub am instead of vector U sub am from vector U sub an. Vector U sub nm will be the red vector shown on the right, and be written in formula as follows. Vector U sub nm 213.6780 times sine of 120 pi t plus 180 degree minus 57.7776 degree equals 213.6780 times sine of 120 pi t plus 122.2224 degree.